Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Nurul Farah MPT Nurhan. My matrix number is DE210088. So our project is steady state stability analysis of power systems with photovoltaic integration. So let's start. So to start off, the introduction for our project is the topic is, does the world dying has anything to do with power generation? And the answer is yes. It is due to the depletion of natural sources such as fossil fuels has forced the entire global economy to take an immediate action. Thus, it has become a global interest for every country to implement the renewable sources as their power generation. So this project actually is to understand the penetration of PV installation within the power system industry. Why this is important? Because each country has its own differences, and this PV installation is affected from reasoning such as the weather and also the positions of the country itself in the map. So the logical reasoning why this project is important also is for us to understand that photovoltaic installation itself has its cons and pros. So this project will highlight the pros of this installation by highlighting the stability state of the voltage itself.
Assalamualaikum, my name is Johan Bezakuan. My matrix number is CE210148. So I will continue the presentation for the project. Okay, for problem statement, the first problem statement is the integration of photovoltaic PV systems into power system presents stability challenge. Okay, for the second one is the substantial penetration of PV power generation require strategies for maintaining steady state stability. Okay. For the third one is the intermittent nature of PV generation and increasing electricity demands raise concern about power system stability. Okay. So for the objective of the project is to assess the impact of PV integration on power system stability and identify associate challenge. Okay. The second one is they investigate the relationship between PV integration and supply capacity, considering power generation and system infrastructure. Okay. The third one is to perform steady state analysis of power systems with PV integration, focusing on voltage stability and line voltage stability index. Okay. For the last one is to develop strategies and control measure to mitigate stability issues in power system with PV integration. Okay. So we'll pass to the next presenter to explain more about the project.
So very good day to Dr. Emily, and I'm gonna to present about the result of our PBL section. So I'm gonna to present about the steady state stability analysis, and our analysis is about IE 30 bus. And this reference that we get from online book. So this is the data of the IE bus, show the bus voltage, generation, and the load, about the magnitude, the voltage per unit, and the real megawatt, and the reactive power of the MVAR. Okay. So through the result, we also use the MATLAB. Is through a platform MATLAB to show about the result that we get from the reference is accurate. So this is a MATLAB code that we search from the website, and we also got changed about the generating load with the power limit to our reference. So we start simulate it, and we will show the initial result. About the Newton-Raphson law. loop flow solution. And this, as a reference, we set the bus 30, number 30 for reference. So we get a 0.984 volt compared to the original result, 0.9932. So it's similar, and we will start our analysis through 100% increment for the load plus. So we go back to the simulation, and from the bus 30, we change the value of the load, power load of the reactive power and the by increment 100%. So the power load will become 21.2, and for the reactive power will be changed to 3.8. And we simulate the MATLAB again, and we will get a data of the voltage per unit is 0.932 per unit. So we will return to increase the increment until the system collapse. So we will going through for the increment 100% again, and now this time we're gonna to use the power load is 42.4, and the reactive power will be 7.6. And this is the value of the bus number after the increment of 400%, and we will get 0.739. So by looking at the voltage PU after the increment, we can see that when the load of the power increase, the voltage per unit will also decrease linearly. So based on the system didn't collapse, so we will continue to increment another 100%. Okay, so now the system is collapsed. Okay, so based on this, the result, we can going through for the discussion, and I will let my teammate to discuss about the result. Thank you.
Hi everyone, my name is Lishalini Murugan. Today I will explain the three mainly used control strategies for steady state stability enhancement. So the first one is droop control. Droop control is a decentralized control strategy that regulate the output voltage of inverters based on the load current. It introduces a voltage droop characteristic where the output voltage decreases as the load current increases. Thus, by using droop control, PV inverters can share the active power and also reactive power in coordinated manner, which helps stabilizes the system during steady state condition. And the next one is virtual impedance control. Virtual impedance control usually involves emulating an equivalent impedance between the PV inverter and also the grid. Thus, this virtual impedance helps regulate the power flow and improve system stability. By adjusting the virtual impedance parameter, the PV inverter can provide dynamic power support during grid disturbance, thus enhancing steady state stability. And the last one is power oscillation damping, POD control. POD control aims to dampen power oscillation in the system by injecting damping signals into the control loop. It utilizes the measurement of system's oscillatory mode and also calculate appropriate control signal to counteract the oscillation. Usually, POD control can improve steady state stability by mitigating the power functions caused by disturbance and also system dynamics. So that's all from me. Thank you.
Hello, Assalamualaikum. My name is Muhammad Amirul Naim bin Muhammad Nazari. My matrix number is CE210027. So now I want to present my part, which is PV integration analysis. So first is incorporate PV generation system into the power system model. To incorporate PV generation systems into the power system model, data on the PV system, including capacity and location, is gathered. Then the system representation level, whether aggregate or granular, is determined. Solar irradiance data is utilized to estimate the incident solar energy. A model for PV system performance based on irradiance and capacity is developed and integrated into the power system model. The model is validated and calibrated using real-world data, and various scenarios are analyzed to assess the impact of system ability, uh, voltage profile, power flow, and economics. Then is investigate the impact of PV integration on steady state stability during different operation scenarios. Investigate the impact of PV integration on steady state stability by analyze its effect during different operation scenarios. This involves assessing PV penetration levels and their effects on system stability, analyzing voltage, profiles and potential deviations, evaluating power flow and line loading. Ah, Studying the interaction between PV inverters and the grid. Investigate the impact of PV generation variability on system frequency stability, analyzing the need of reactive power compensation device, and assessing system oscillation and damping characteristic by considering various scenarios. The influence of PV integration on steady state stability can be truly examined. Then the last one is analyze the effect of PV system parameters, example capacity, location, control strategies on steady state stability. Analyze the effect of PV system parameters such as capacity, location, and control strategies on steady state stability. Assess the impact of different PV system capacities on stability and study the influence of system location on voltage profile and reactive power flow. Evaluate the effect of various control strategies. Implement PV system on stability. Consider system characteristic, including efficiency and temperature coefficients. And analyze their impact. Investigate the interaction between PV inverters and the grid, including control parameters such as droop control and power factor setting. Analyze dynamics, oscillation, and the influence of variability. Perform sensitivity analysis to identify critical parameters affecting steady state stability and consider interaction with other system components. So that's all from me. I will pass to the next presenter. Thank you.
Okay, for the conclusion, so this project has explored the integration of photovoltaic PV systems into power systems and investigate their impact on stability. So the project has focused on accessing the relationship between PV integration and supply capacity, particularly in terms of power generation and system infrastructure. Through load flow analysis, steady state stability analysis, and PV integration analysis, the project has identified challenge related to system stability and proposed control strategy to mitigate this issue. Okay. So these strategies include group control, visual impedance control, and power oscillation damping, which is a POD control, each with its own effectiveness depending on the specific system requirements and grid condition. Okay. So overall, the finding emphasize the significance of incorporating PV systems into the power generation mix while addressing stability concern and ensuring a sustainable and resilient power supply for the future. Okay, so that's all for our group. So thank you.